Today what you're going to be doing is the probability problems that we started on Friday. And these are just another way of figuring out the probability of offspring when given the genotypes of two parents without you having to do the Punnett square. Basically, it's the same thing. It's just a different method, a different strategy for doing that. And when you're dealing with multiple crosses, multiple traits, it prevents you from having to do a 16 or 64 square Punnett square. So it just makes it a little simpler. So what I want you to do to begin with is pause the video. You should have the goldish yellow worksheets. I want you to read those instructions and then resume the video. So before we get started, we're going to look at the example that's given for you on the worksheet. We had gone over this on Friday, but let's go over it again and explain what they've done to make sure that you understand how they got these results, okay? So for each genotype, basically what you're doing is just figuring out what the answer, the results will be in a Punnett square, all right? So these are what we're looking for. We're saying that if these two parents with these genotypes had offspring, what is the probability that they could have, homozygous A's, heterozygous B's, and then heterozygous C's, given the genotypes of the parents listed? Okay, so what you would do is you want to see how many times you can take these two parents' genotypes and get A, both capitalized, both dominant, out of that. Well, you could have dad's A pair with mom's capital A here, or you could have this A from dad paired with that A. So then you tell how many arrows you got. We got 2 arrows. All right, that's the only other possibilities, because the only other thing that it could be would be this A go into this lowercase a, and that's not what we want. So that's not what we're doing, okay? So we're just trying to see these particular desired traits, the capital A and lowercase a. Okay, so here we're looking for what are the probability, what's the chance that we could get a big B, little b, a heterozygous. Okay, so if dad's capital B here paired up with mom's lowercase b, that would give us a heterozygous genotype. Or if his lowercase b paired with mom's dominant gene, then that would give us what we're looking for, heterozygous as well. And that's the only choices we got, that we have. So that also would be 2 arrows. Okay. Now the final one, we're looking for heterozygous as well. So dad's dominant C here could pair with mom's recessive there, or his dominant could pair with this recessive, or his dominant could pair with that recessive, or it could pair with that one. So you actually have all 4 possibilities for heterozygous there. So our fraction would be, we consider this out of a Punnett square of 4 squares, 4 different possibilities. So this would be, right here would be 2/4, which equals 1/2. This one would be 2/4, which is 1/2. And this one is 4/4, which of course is 1. All right, then you're going to come in and you're going to multiply all of those values to find out what the probability is that you would be able to get all 3 of these genotypes in the same individual, in one offspring, okay? So when you multiply 1/2 times 1/2, that gives you 1/4, times 1, then is going to be still 1/4. So you have a 25% chance of having offspring that have those particular traits, okay? So I want you to flip over onto the back of your worksheet. Pause the video here, and I want you to set up the parents and desired offspring in a chart, just like we did in this one, in this example. And then when you finished getting that copied down, then resume the video. This is problem number 1 on the back of your worksheet. Okay, so you have a dad who is homozygous for all 3 of the dominant traits, and then mom is homozygous for all 3 of the recessive traits. But we want to see what is the chance that they will be able to have a child who is heterozygous for all 3 of those traits, okay? So our desired trait that we're looking for in the first one, in the first set with these genotypes, is dominant A, recessive A. So if you pair dad's dominant A with mom's recessive A there, you could also have dad's dominant A paired with that recessive A. It could be done here as well, or it could be done here as well. So there's 4 arrows. All 4 possibilities would be dominant A to recessive A. Okay, you are here looking for dominant B and recessive B. So dad's dominant paired with mom's recessive could happen exactly the same way. Okay, so again, you have 4 arrows that were drawn. And the last one is also heterozygous. So you have dad's dominant with mom's recessive there, here, and here. So again, 4 more arrows, okay? So your fraction on these would be 4/4, which is equal to 1. Again, 4/4, which is equal to 1. 4/4, which is equal to 1. So you have 1 times 1 times 1, which equals 1. So in percentages, that is 100% of their children are going to have this genotype. They're going to be heterozygous for all 3 traits. Okay? I'm going to work out number 2 with you, but what I want you to do is pause the video, work out number 2 on your own, and then resume the video to check your answers and make sure that you got the correct answer. So this is question number 2, okay? So again, these are the desired offspring that you're looking for. So you've got these genotypes then for your parents up here, okay? So we want a dominant A and a recessive A together. So you could pair this way with dad's dominant A to mom's recessive A, or this dominant to recessive. So that is 2 out of 4 again, okay, which will be equal to 1/2. All right. Here we want homozygous recessive, so you could have dad's recessive paired with mom's recessive, and that's really all. Any other way that you pair those, you're going to get something different. So it is 1 out of 4 squares, so that is 1/4. And then here we want homozygous dominant. So dad's dominant C could pair with mom's dominant C. And again, that's going to be all that you can get from that one. So it's 1 square out of 4. So that is 1/4. Okay, so then you multiply those together. Okay, and if you multiply those together, you have 1, of course, as your numerator. Your denominator, you're going to have 2 times 4 is 8. 8 times 4 is 32. So that is 1 over 32. Now, if you did the math on that and put that in a percentage, it is going to be 3.125%. Okay? So this would be your percentage of offspring from those 2 parents that would have this particular genotype. Okay, so what I want you to do, you have 10 total problems, so we've worked out 2 together. You have 8 more that you need to finish, so I want you to finish this doing exactly the same way we've been doing. Set up your table. All of this work is due at the end of the class period. If you need to staple these together, if you have multiple pages, you can do that. The stapler, you can pass that around. I want you to turn in the gold sheet or the yellow sheet and your answer sheet before leaving class today. If you don't get finished, I still want you to turn in that work. So whether you are finished or not, please turn in your work at the end of class.